Hi everyone, welcome back to the session. So today session we're gonna covering up the revision of the DSA series that we've been started earlier. So for now that I will be talking about quick actually I will say quick definition of the each and every topic that we have discussed on the DSA series. And for that I have just need to search the roadmap that we have actually looked for earlier. So here we have so key data structure that been discussing through the DSA series. That's the basics of indexing operations like searching, inserting, right? Arrays, strings. We have discussed the how strings are stored. Operations like subtract, substring, reversing, finding pattern, and linked list we have seen singly linked list, doubly linked list, operations like insertion, deletion, and traversal, stacks and queue. In that LIFO, FIFO structure, implementation of using arrays or linked list we have seen here. Hashing we have seen, learned hash maps and the sets of the efficient lookup that we have seen here, right? And trees in that the binary trees, binary search tree, and operations like traversal, right? And order, pre-order, post-order, insertion, deletion, and searching we have seen here, right? For an example of that, binary tree in order traversal, lowest common ancestor in BST, maximum depth of binary tree. So graph we have seen here that represents a graph of a DFS BFS cycle detection. Example questions we have number of island, shorted path in graph, detect cycle in undirected graph. Heap we have seen very recent time that mean heap and max heap and priority key, right? Eighth largest element in a merge case. Okay. So that's what we have seen here, right? And can talk about the algorithm, that what kind of algorithm are there in the sorting algorithm. So bubble sort, selection sort, insertion sort, merge sort, quick sort, and their time complexities, right? So these are the things that we have discussed. Searching algorithm like linear search, binary search, and their variations, right? And recursion, that learn the basics of recursion and solve the problem. That can be broken down into the sub problem. So that's what is that. Backtracking is useful in the problem that requires finding all possibility solution. DP we have seen. So breaking problem into overlapping sub problems. So which means that the Fibonacci sequence. So longest common sequence, coin change problem, greedy algorithm here. So make locally optimal choice in the hope of finding a global optimum. That's what we have seen here. And gonna have to be look up for that. So we have seen about the arrays to some maximum sum like string, linked list, stack queue, trees, graph, DP. DP refers dynamic programming, recursion, backtracking. Time complexity, space complexity, both are really essential for that. If you have optimizations of the solution, and that's what that keeps very into the stick into the topic that what you were talking about. That's what here we've been discussed. And I'm gonna be look up for the arrays. Arrays and strings are these two what to say, topics that most actually important. And in many questions you can see around the arrays and string itself, cause that they most of the time somebody is has to be actually get into the coding part. So these are the these two topics are really important, and will be looking forward for get it do it again for that. uh, for now what's that next, so we'll be discussing about AIML things more properly, or don't know, but that's what in my mind. And for the DSA session, this is all about the DSA that we have discussed here. And the last topic, the today topic, right, the today session was all about revisions that what we have gone through that. So it was a quick view overview, you can say, and really looking forward for to the get into more revisation, wanted more revisation of that things, and that's what. And so by now that's all of my time for the today. We are finishing the DSA series of the session, and see you in the next, catch you in the next, and bye, peace.